Hey guys, we're going to do the next group of questions, which has to do with confidence intervals. And also, I think there's one on here with the stat test dealing with proportions. So the first question for one, it says, an ag company is testing a variety of wheat. It was determined that the portion of the crop was 0.4, right? And maybe there's a sneaking suspicion it's something less than that. Which of the following significance level and sample size would lead to the highest power of the test? So our notes say to increase power, we can increase N or we can increase alpha. So I'm going to ratchet up N as high as I can and eliminate these answers. And then I know this higher one would actually be a much easier way to detect if there was a low probability. Notice D would be much harder. That's much harder to meet. So if you ended up getting the probability of 4% or 3% or 2%, then under D, you still wouldn't, the power wouldn't detect the issue because you set alpha too low. Okay, next question, it says number 4 is under this same type of question. So it says a school board in certain school districts obtained a random sample of 200 residents, asked who was in favor. So notice they're asking a yes or no question. Are you in favor, yes or no? Okay, so that's a proportion. And so these are proportions. The resulting confidence interval told us the true proportion of those in favor. What would be the margin of error? So our notes say that we have a point estimate plus or minus our margin of error. You could logically figure out where this number is in the middle, what number falls in the middle of this, and then figure out, okay, it looks like it's like 0.21, 0.22, and then what's the distance between on either side of that? But we do have a formula that's useful. So to find the point estimate, they don't ask for that here, but to find that, you just want to find the average. So you'd, if this is our upper bound and our lower bound, you would add the 2 and divide by 2 to find the point estimate. Here they've asked for our margin of error, so you're going to subtract the 2 and divide by 2. That should tell us how far apart they are. All right, so that would be 0.257, take away 0.183, divide by 2, and let's see what we get. And I get one of my answers, so that's exciting. There we go. So we get part A. Next question, also having to do with confidence intervals, we jump to number 11. Number 11 says, a survey firm wants to ask a random sample of adults if they supported. So again, this is asking a yes or no answer. It is a proportion. Let P hat be the sample that said they support it. Suppose that 40% do support it. So we're going to set our P hat at 40. Even though we don't know what it is, we're supposed to suppose. If the survey wants a standard deviation of the sampling distribution to be equal to 0.01, how large would the sample size need to be? So this is a lot like our badge 1 with a twist because we're solving for our sample size, or N. So let's look at our formula sheet to see if we can piece this out. So we look on our second sheet of our formula sheet. It says for one population, right? And our standard deviation of our sample or a sample statistic is this formula right here. And that should look familiar. Okay, so they want our standard deviation or a standard error to be 0.01. And we know that would be P hat 1 minus P hat over N and take the square root of the whole thing. So they want the standard error to be 0.01, and we know our P hat we're supposed to set at 0.4. So we just have to do some algebra magic to solve for N. So step 1, I'm going to square both sides. So this side, I get that, and this side just turns into 0.4 times 0.6 or 0.24 over N. When I square 0.01, I get, I'm going to write this over here, I get that, and 0.24 over N. Now I'm going to do a length swap. Let's swatch spots there. All right. And we get 2,400. Nice work. And that is our answer. All right, 11 is down. Now let's look at number 15. It's also one of these confidence interval questions. It says a Harris poll found 54% of American adults don't think human beings had earlier species. The poll gave a margin of error of 95% with a confidence of was 3%. What does this mean? Well, it essentially says our point estimate plus or minus our margin of error. So they found that it was 54% plus or minus 3%. Okay, so somewhere around 51% all the way up to 57% said that. Okay, what does this mean? Well, when we do it, that means we're 95% confident that the interval from this to this captures or contains the 2% of Americans who don't think these species developed. So A matches our script. Okay, so if you miss this question, make sure you write out the script to help you memorize the script. Okay, last question, number 31. So let's take a look in this section. It says a city wants to conduct a poll of taxpayers to determine the level of support for constructing a new city-owned baseball field. Which of the following would be the main reason for using a large sample size? So remember, if you increase the sample size, you increase the power of the test. So you want to be able to be powerful enough, right? We've said multiple times, just by asking more people, it won't increase our confidence level. If we did a 95% confidence level, but instead of asking 200, you ask 500, it's still a 95% confidence level. So it won't affect this. It won't eliminate confounding variables. It won't reduce any bias. It won't reduce undercut. By asking more people, let's say certain people that don't have phones or certain people who don't want to answer the question or whatever it is, the only reason for increasing the power of the test or to increase the precision of the estimate, we can have a much more precise estimate. And this is what I call the Hillary Clinton. So remember, we said if I have a big margin of error and she doesn't like it, by asking more people, I can actually whittle this down to a much smaller margin of error. This provides a more precise estimate. Okay, that's all we have in this section. Check out the next one for more